Today, we're going to go ahead and learn how to graph cosecant and secant. In order to graph the cosecant and secant, you want to be very familiar with the cosine and sine because we need those in order to draw the cosecant and the secant. So we're going to start here with our cosecant graph. So y equals the cosecant of x. If we think about what the cosecant stands for, it is the reciprocal of the sine. So cosecant of x is equal to 1 over the sine of x. That's why you want to be familiar with the sine and cosine graphs, because we're going to use those to graph. The period of the sine graph is 2 pi, so the period of this one is also going to be 2 pi. So here's our graph. In order to graph this, we start by graphing our cosine graph. Now I'm going to make this 1 right here and this -1. So the tick marks, 2 of those tick mark makes 1, just so that I can show you the graph better. So if you remember the sine graph, it starts at 0. It goes up to 2 pi, is one full cycle of our sine curve. It is back in the middle at pi, and it goes up and then down. So this is one full cycle here of our sine curve. That means it would be here, and then I'm going to finish that off on this side. And some people go ahead and draw the entire sine curve there. Some people just draw the points of the sine curve because that's really what we need. So our cosecant of x is 1 over sine of x. Well, we know when this denominator is 0, it makes it undefined. So our cosecant of x is going to be undefined anywhere where sine is 0. Well, that's easy to see if you have our graph here. It is wherever it crosses the x-axis. So it is going to create an asymptote anywhere it crosses the x-axis. That's where it's undefined. So there is our asymptotes. Once you draw the asymptotes in, then the cosecant graph is going to be from the vertex of that sine graph towards the asymptotes, because remember, asymptotes guide your end behavior. So here is our cosecant parent function. Now we said the period is 2 pi. So, just forgot this one here. So if we look at this graph here, for our period of 2 pi, that's from here to here, that is one full cycle of our cosecant graph. It is 1 up here and 1 down here. That's one full cycle. Then it starts to repeat, so we see it up on top again, same thing here and on the bottom. Again, this sine curve part is not part of the cosecant graph, only these parts. So I'm going to go ahead and graph it on a calculator just so that you see that. There is our cosecant graph. And again, one period is 2 of these, so this would be 2 periods of our cosecant graph. So that's our parent function. That's the one that we would start with anytime that it says cosecant. So now let's do the secant graph. And our secant graph is going to be 1 over cosine of x. Remember, that's the reciprocal of cosine. The cosine also had a period of 2 pi, so this is going to have a period of 2 pi. And we start by drawing the cosine graph this time. And so our cosine is the one that starts up on top here. And then at 2 pi would be back at that point. In the middle, it is all the way down to the bottom, and then it crosses the x-axis in between. This is one full cycle of the cosine graph. And then it repeats. So I'll go ahead and put my repeat values here. So there you go. Again, you do not have to connect these points if you don't want to, since it is not part of the graph. Just like with the other one, anytime that our cosine graph is 0, it makes our graph undefined. So we're going to have our asymptotes there. I'm sorry, I drew those with the marker. Should have drawn those with the pencil. So those are our asymptotes. And then we go from the vertex towards our asymptote, since they guide the end behavior. And there is our graph. Again, you'll see that a full cycle is going to be 2 pi. In that case, it is from here to here. And so we kind of have a half of it up here, a full, and then another half. That is one full cycle right there of our cosine graph. So these are the parent functions. In many cases, you're going to be asked for the asymptotes. And so to represent the asymptotes here, you would start with the first one. So with our cosecant graph here, the first one is at 0, and then we have one every pi. So we can say x is equal to n pi, every single pi. So if I put 0, 0 times anything is 0. If I put 1, that's going to give me 1 pi. If I put 2, that's going to be 2 pi, and that will represent every single asymptote. Over here with the secant one, we would have our first one at pi over 2 right here. So that's pi over 2 plus every pi unit again would be an asymptote. And so we would say n pi. Since this one did not start at 0, that's why this one is missing here, because 0 plus n pi would just be n pi. We have to have our first one, so pi over 2 plus n pi. If I put 0 here, that's going to give me my first one at pi over 2. If I put 1 over here, that's going to give me my next one at 3 pi over 2, and so on. If we did the negatives, then it would go this way, but that gives us every single asymptote. So here's our two newest parent functions. We've got the sine, we've got the cosine, now we've got cosecant and secant. Those are our two parent functions. So now we're going to go ahead and graph those with some transformations. So let's look at graphing those with the transformations. Right here at the top, it tells you to graph the cosecant and secant graphs. You're going to start by graphing that sine or cosine, and that includes with the transformations. Then we do all the shifting that we need. We do not connect the points if you don't want to. You draw the asymptotes through that middle point, and then we sketch the reflections of the graph from the high or low points. So here we go. We've got y equals 3 secant of 2x. So we're going to start with it. And just as a quick reminder, that's what the transformations look like right there. Y equals a times the secant of b times x minus c plus d. So in the place here of a is 3. In the place of b, we've got a 2. There's no c value, and there's no d value. So that means it's not going to move right or left, and it's not going to move up or down. Now, with these graphs, secant and cosecant, since it does go up and down forever, there's no amplitude, so this would be none. For the period, we're going to take that 2 pi, which is the regular one, and we divide by 2 here. And so 2 pi divided by 2 is pi. That means every pi distance, we're going to have a full period of the graph. It wants us to sketch and write the shifts here. There's no shifts because we said it's not going to go left or right or up or down. So here we go. Let's look at these, this graph here to graph that. We start by graphing our cosine or our sine. This is the secant. So we would want to sketch the cosine. I guess I could have wrote that here. And you are going to sketch that cosine just like if it was a cosine there instead of a secant. So I am going to go ahead and actually sketch the graph of, 3. Three cosine of 2x. All right, so to sketch that one first, our cosine is the one that starts at the top. It has an amplitude of 3 here. So I'm going to go by ones, 1, 2, 3. This right here would be the highest point on my cosine graph. Now, I'm just going to sketch some dotted points there just so I know how high it goes. Then -3 is going to be how low it goes. Because remember, for the sine and cosine graph, this is the amplitude. And so there's my highest point and my lowest point. The cosine one is the one that starts at the highest point. So this would be my first point. it has a period of 1 pi. So 1 pi distance away, I know I'm going to be back on that same spot right here. In between those, I will be at the bottom. And then in between those, I would be on the x-axis. Again, another pi, and I'm going to be right there. In between those two, I'm at the bottom, and in between those, I'm on the x-axis. The better you know that parent function, the easier it is for you. I'm going to do the same thing for this other side. 1 pi, I'm back at the top. In the middle, I'm down. And in between those points, I am on the x-axis. Another pi here, down, and in between those two. All right, now I have those points. I'm not going to connect the dot on this one just so that you can see what the actual graph looks like without those values. When it is on this middle value, those are our asymptotes. So I'm going to draw those next. So I draw my asymptotes here. Remember on the test, we need at least 3 periods. If you want to draw every single one of them, you can, but just draw at least 3 of them for when we're grading. This one has a lot. Since our period is 1 pi now, we're going to see a bunch more. That's the reason why we're having a lot more asymptotes here. There's all my asymptotes. All right, so now I'm ready to graph our actual graph. So we know the top point and the bottom point are going to be our vertice point. So this right here is going to be my vertex, and then I'm going to move towards the asymptote. So I get a piece right there. And I just do that now for every single one of those vertex pieces. One period is 2 of these, so as long as you have so 1 period, 2 periods, 3 periods, as long as you have that many, you are good for the test. But there's the full graph. This is a pretty neat graph to draw, since you've got all of these different parts that go into it. All right, so just to summarize that, we started with the cosine, so it starts at the top here. This would be my 1 cycle of the cosine. So all I need is the points. The ones that are in the middle here give me my asymptote. The one that's at the bottom and the top gives me my vertex for that secant graph. So there's a shift. We're going to go ahead and try some more. Before I go to this one that has a bunch of shifts, I'll go ahead and try a couple more that doesn't have quite as many shifts. So on our blank graphs, that's where we're going to go. All right, so let's try this one. It's y equals 2 times the cosecant of x plus pi over 4. All right, so this is still considered the vertical stretch, just like we talked about even from Algebra 2. Again, it doesn't have an amplitude because it's the cosecant. This right here is the left pi over 4. Remember, when it's a plus here, it's left. If it's a minus, it would go to the right. And this is pi over 4, so it is going to move to the left pi over 4. All right, in order to graph this one, again, we start by, and I'll just write it down here. We're going to start by graphing 2 sine of x plus pi over 4. And we're only going to do the dots again just to know where we stand. So this has that amplitude of 2 for the sine. For the cosecant is not an amplitude because there's no amplitude for cosecant since it goes up and down forever. So for our sine curve, I'm going to do my minimum here at -2, and I'm going to do my maximum at +2. The sine curve is the one that starts in the middle here at 0. Now we do have to move it to the left pi over 4. So from the 0, I'm going to move it to the left pi over 4, and so there it is right there. For the rest of it, it is still going to have a period of 2 pi since we did not change the b value here. It's still 1, so the period is 2 pi. And so for 2 pi, we've got 12 units. 2 pi is represented by 12 units. So I would go 12 units. And there's my final point for that sine curve. In between that, so 6, so 1, 2, 3, 4, 5, 6, I'm back in the middle. And the sine curve is the one that goes up and then down. So 1, 2, 3, and I'm up. 1, 2, 3, and I'm down. 1, 2, 3, and I'm up. Can't go any further there. 1, 2, 3, and I'm down over here. And so there is our sine curve points. Now remember, when it's in the middle, that makes my asymptotes. So I'm going to have an asymptote at every point that it is in the middle. So I'm going to go ahead and draw my asymptotes next. There's a lot of pieces that go into this, so you're going to want to practice so that you can get really good at graphing these. Because there's so much to remember. So there's all my asymptotes. Now we're ready to go ahead and graph our graphs in here. So I go to my asymptotes and my vertex. And I take that vertex and I move it towards the asymptotes. And so there is our graphs. This right here would be the cosecant graphs, the part that you see in blue. Graphing this sine curve inside here is just to assist you to graph that cosecant one. All right, let's try now one with our secant. All right, so we're stepping it up a little bit more. We've got 3 transformations now. This right here is up 1. This is to the right, pi over 2. And then we've got a vertical stretch by 2. You should be really comfortable with those transformations. You've been doing them since Algebra 2. None of them have changed. Since this is a secant graph, I will start by sketching the cosine graph. So I start by sketching that graph right there. This one went up 1 unit. So our new middle section is going to be right here instead of on the x-axis because we've moved the entire graph up 1 unit. Its amplitude is 2, so I know it's going to go up 2 from there. So that's going to be at 3, and it's going to go down 2, so that's going to be at -1. That's where my high and low points are going to be for that cosine curve. The cosine curve starts at the top, so that would be right here. Now it is moving to the right pi over 2. So at pi over 2 is where my point is going to start. That's going to be the first one. Everything follows from that point. We didn't change the period, so it's still going to be 2 pi. So a 2 pi distance away would be right here. That's where 1 full period of our cosine curve is going to occur. Now the cosine in between these 2 points falls at the bottom. So right here at 3 pi over 2, I'm going to be at the bottom. And then in between those, I'm going to be in the middle. And then I follow along on that same pattern. And so there is our cosine curve. Remember, I do not have to connect the points. I just need those in order to graph my secant graph. The next thing I'm going to do is my asymptotes. The middle term, the middle graph here is where my asymptotes occur. So everywhere that would be, I get an asymptote. And then we go to our top and bottom points, and those are going to be the vertices of our graph. There's our secant graph. These aren't hard, you just want to practice because there's so many steps that go to it. All right, now we'll do that hard one. We're going to go ahead and finish with this one. I say hard, it's not harder, it's just got a lot more transformations. We're going to try and stick to 2 to 3 transformations on the test, but this one has every single transformation just so that you can see that happening. So right here, we've got our vertical stretch of 3. Our B value is 1/2. Our C value is pi over 2, and our D value is 4. All right, so we'll start real quick with these shifts because that's usually the easiest part. So this is going to shift to the left pi over 2, and it is going to go up 4 due to those two right there. There's no amplitude on a cosecant graph, so we can just write none there. For our period, the period is 2 pi for the cosecant graph, but now we've got this b value of 1/2. So we need to divide that by 1, 2. Students don't like this because of the fraction, but remember when you're dividing by a fraction, you keep change flip. So we're going to keep that 2 pi. We're going to multiply times the reciprocal of 1/2, which is 2. So we get 4 pi. In this case, we're only going to have one full cycle within 4 pi. We start by graphing 3 sine of 1/2 x plus pi over 2 plus 4. So that's what we're going to start by graphing first. In this case, it went up 4. So 1, 2, 3, 4. This is my new middle line. And don't try and skip doing these steps because it makes it a whole lot easier if you've got the lines on there for you. The amplitude for the sine graph is 3, so I know it would go up 3 from here. And down 3. So we've done the up 4 by moving that middle. We've done the amplitude of 3 by leaving 3 down and 3 up on this graph. Now we're ready to do the others. And so a sine graph starts right here in the middle at 0, 0, which in this case would go up 4. We need to move it to the left, pi over 2. So my first point is going to happen right here. Now, I need a full period of 4 pi. That would be off of my page here because this only goes 2 pi right here, and then another pi over 2 doesn't give us enough for 4 pi. But we can start thinking through this. So at 2 pi distance from this, I should be back at the middle because our sine curve looks like this. So I know that at this point is our first one. 4 pi would be here, and so 2 pi would be that middle point in between those two. So a distance of 2 pi away, I need to be back at the middle. So I'm going to go 2 pi from here. There's 1 pi right here, and then another pi right here. So I'm back at the middle. In between those two, I would be at the top. Now I'm going to go a distance of 2 pi this way. And in the middle of those two, I would be at the bottom. So that's all I'm going to get really on this page. When it's in the middle, it is my asymptote. So I'm going to have an asymptote there, and I'm going to have an asymptote here, and another one right there. Now I'm ready to draw my cosecant. This one is way wider. Now we got one period in a total of 2 pi. So 4 pi. The entire distance from here to here is 4 pi, and we've got one full cycle. which is 1 on the bottom and 1 on the top. So this horizontal stretch by 2, remember that's called a horizontal stretch by 2, is what's happened here. We pulled it this way, giving us 1 full cycle in 4 pi. So that was just a lot of transformations there for that one. Again, that's the hardest you're going to see. I hope you can graph the cosecant and the secant graph now.